So this is our first example where we try to prove a propositional function in terms of n. Let's assume this is P of n, a statement in terms of the integer n, which we want to prove by mathematical induction. Okay, so before we start the proof, I want to highlight this fact again, that the principle of mathematical induction can prove the propositional functions, but it may not be a very good strategy to be able to arrive at certain propositional statements. Okay, so it can only be used to prove statements which are already there, but it's not a generative proof method which will help us generate propositional functions. Okay, so how can we prove this formula, which is true for all integers n? So following the process of principal mathematical induction, we try to have the basic step first, which means that we try to establish the truth of this statement for n equals 1. If we look at the formula and focus on this summation part, if we have n equals 1, then there is only one term in this summation, which is just the first term in the sum, that is 1. Okay. While this formula says for n equals 1 that this side of the formula, if we put n equals 1, we will have this arithmetic expression. So we put n equals 1 here, here, and then we simplify it and we get 1. Okay. So we see that both this side is 1 and this side is also 1 for the basic step.